Having a look at the enzyme required practical for enzymes in the biology class. So what the purpose of today is to see the enzyme we're going to be examining is amylase. Amylase breaks down starch. So I have in this beaker a starch solution. Both of those are 1% solutions. We also have the variable is going to be the pH value. So I've got a pH 4, pH 6 and pH 8. You'll notice all of these are in the water bath, which is set to read about 30 degrees. We've put the thermometer in there because actually, as you can see, it's slightly below 30 degrees on here, but I trust the thermometer to be more accurate. We will be using quantity, a proportion of each of those chemicals in a test tube, mixing it and seeing how long it takes for the amylase to break down the starch. The indication that there is starch present is given by iodine solution. It's important that we call it by the name iodine solution because iodine itself doesn't look like this. It's a solid item. So I've put one drop in each of these of iodine solution. Right, literally what we're going to do now is I'm going to do the pH 6 as our first one. I'm going to take a clean syringe, and I want to draw off 2 millimeters, which is the same as 2 cubic centimeters of that solution. So I've got that into my syringe and pop that into the bottom. Pop the chemical back in there because it's important that it's all at the same temperature. That's one of the constants that we can show. I'll take the amylase with a fresh syringe and draw off 2 millilitres of this. Just a little bit far. So at the moment that should be still quite inert. There's nothing for the amylase to be doing. It's literally just in a bath of pH 4 buffer, what's called a buffer. Now then, the book will normally show that we should add 2 millilitres, i.e. the same amount of starch as we had amylase, but the experiment works much better if we put more starch in. So I'm actually going to draw off 10 millilitres, so we're basically 5 to 1 proportion starch to amylase. I'm going to pop that straight in there. I'm going to swill it with one hand while I start the timer with the other. So that's in. I'll be swilling that and we'll start our timer. Oh God, done it wrong again. Start our timer. So I've got a stirring rod here. When that gets to 10 seconds, I'll touch the water into there, the solution, and that's showing us that it's purple. So we've got a indication that there is starch present in the solution. Every 10 seconds we should be putting a drop in. So I'm going to put another drop. In between times, please note I'm rinsing this out and drying it out in just a water to make it clear. 30 seconds. And we can see already that the colour is changing. We're looking for there to no longer be an indication. 40 seconds. You're looking for the colour change to go away from being starch being present, so we should actually stay with about the orange colour staying the same, the iodine solution staying the same. So we're now at 1 minute and we can see quite a significant change in that colour now. Keep rinsing it each time. And there we go, we can see that it's changing slowly but surely. We're obviously looking at changing at the stopping the clock, sorry, at the point where the starch is no longer showing an indication in the solution. So we're now 1 minute 30. Still a tiny trace, slight colour change. Rinsing and stirring in between times. Minute 40. I'm very hopeful we're going to get to a good proper change here. And that's it, nearly done at 1 minute 50. And there we go, at 1 minute 60 I would say that's barely changing, so we're just about on the turn at that point. So that's showing 2 minutes for the amylase in pH 6 to do the colour change and completely break down the starch.